Solving absolute value equations. First, let's look at evaluating expressions. Plug a value in for the variable and solve. The absolute value of 4 is equal to 4. The absolute value of negative 4 is equal to positive 4 as well. The absolute value is the distance away from 0. That means it's 4 units away from 0. The absolute value of negative 4 is also equal to 4 because it is also 4 units away from 0. The absolute value is never negative, it's always positive. Here we have 8.4 minus the absolute value of 2n plus 5, and let n be equal to negative 7.5. That means we're just going to plug in for the value and figure out what this is equal to. So 8.4 minus, inside the absolute value we have negative 15 plus 5. Then we have 8.4 minus, inside the absolute value we have negative 10. The absolute value of negative 10 is positive 10. So 8.4 minus 10 is equal to negative 1.6. And that's how you evaluate. Let's look at solving some absolute value equations. Because the absolute value is the distance away from 0, and there are two possible numbers that can make that positive, the absolute value of a negative is positive and the absolute value of a positive is positive, then I will have two possible answers. Let's look at the first one. We have 9 equals the absolute value of x plus 12. The first step is to isolate our absolute value. In other words, is there something added to it or multiplied to it that I need to get rid of first? In this case, there's not. Since it's already isolated, then we set up two equations. We set it up for x equals the negative number, and we set it up for x equals a positive number, because we have two different possibilities. And then we solve. Lastly, we have to check. So looking at this first one, most of the time we see it written in this format. We will have x plus 12 is equal to negative 9, or x plus 12 is equal to positive 9. First, we want to subtract 12 from both sides, and x is equal to negative 21. Now we look at the other side. Subtract 12 from both sides, and x is equal to negative 3. Now we're on step 3. We must check our answers because we might have 1, 2, or no solutions. We check our answer by evaluating and plugging and chugging, just like we did in this previous example. So we have 9 equals the absolute value of negative 21 in parentheses plus 12. We need to see if 9 is equal to whatever this is. That's the absolute value of negative 9. And this is true. 9 is equal to 9. So this is correct. Now let's look at the next equation. 9 is equal to the absolute value of negative 3 plus 12. Is 9, and that's our go, is 9 equal to the absolute value of 9? Well, 9 is equal to 9, so that checks. So the answer is x equals negative 21, or x equals negative 3. Remember what I said about the steps? Make sure we isolate first. In this problem, the absolute value is not isolated. It has a negative 3 times it. So the very first thing I want to do is divide both sides by negative 3. So now I have the absolute value of r plus 4 is equal to 7. Now you can see that the absolute value is isolated, so now we set up our two equations. Step 2. So I have r plus 4 equals negative 7, or r plus 4 equals positive 7. Subtract 4 from both sides, and we get r is equal to negative 11. Subtract 4 from both sides on the right-hand side, and we get r equals 3. Now we must check our work. Both of these are solutions. You must always check your answers because they are not always going to work out. Let's look at another problem. We have the absolute value of x plus 10, and we want to see if this is equal to 4x minus 8. Okay, remember, we have to isolate first. Is the absolute value by itself on one side of the equal sign? And yes, it is. The next step is to set it up equal to the positive and the negative number. So x plus 10 is equal to negative 4x minus 8, or x plus 10 is equal to positive 4x minus 8 in parentheses. So on the left-hand side, let's clean this up first. I do need to distribute a negative 1 to both terms. So we have x plus 10 is equal to negative 4x plus 8. So the first thing I wanted to do is distribute. Add 4x to both sides and subtract 10. So we have 5x is equal to negative 2. So x equals negative 2/5. Here's the first one we have to check. Let's look at the second one. X plus 10 is equal to, here I have a 1 to distribute. That just means everything's going to come out of parentheses. 4x minus 8. At this point, we're going to subtract x from both sides and add 8. So I have 3x equals 18. So x is equal to 6. So I have two possible answers I need to check, 6 and negative 2/5. And 16 is equal to 16. That checks. So this right here is a solution. That's why it's important that you check. Remember, the first thing we want to do is isolate our absolute value, and this is isolated. So the answer is x equals 3. We need to isolate our absolute value first. We do that by subtracting 8 from both sides. Well, now I have the absolute value of 3x minus 2 is equal to negative 7. I can actually stop right here. If I was to set it equal to a positive number and a negative number, there's something that you need to know. Remember the rules of absolute value. Anything inside the absolute value will always be positive. Is it possible for a positive number, whatever this is, to equal a negative 7? And the answer is no. So I already know the answer is no solution. Let's look at the next problem. I need to isolate by dividing everything by negative 2. And here I have the absolute value of 3x equal to negative 3. Again, I can stop because it is not possible for a absolute value to ever equal a negative number. Solving absolute value inequalities. Let's look at the absolute value of x is less than 3. If we look at our number line, since it's isolated, we would set it up to be equal to negative 3 or 3. So it would be between here and here as a possible answer. Because we are going towards the absolute value, going towards 0, this is going to be an and statement. Because it's an and statement, that means we have to come together with our equation. So we set it up as an in-between statement. Negative 3 is less than the x is less than 3. We are trying to say that this is between negative 3 and 3. The solution in interval notation is negative 3, comma 3. Both of these are open brackets because this is less than and this is less than. The absolute value of 6x minus 5 is greater than or equal to 13. Because 6x minus 5 is greater than or equal to 13, it's actually going away from 0. Well, if 0 is here, then my answers will be going away in this direction and in this direction because it is going away from the absolute value symbol. So I set up two equations now to show that. I have 6x minus 5 is less than or equal to negative 13, or 6x minus 5 is greater than or equal to positive 13. And now we solve. So I have two possible solutions. X is less than or equal to negative 4/3, or x is greater than or equal to 3. This is how you write it in set builder notation, x such that x is equal to all of this. This is negative 4/3 with a dot, and remember, because it is greater than, it's going away from the absolute value. So that means it's got to go this direction. Or x is greater than or equal to 3. But because it's going away, it's got to go in this direction. And then one more thing. We want to be able to write this in interval notation. So looking at our graph, this is going from negative infinity to negative 4/3. Because it's equal to negative 4/3, we use the bracket. And then union 3 to positive infinity. So all of this is the answer on this problem. Because the arrow is going away, I know I have two different equations and not one together. It's going away. So we set it up. Negative 4x minus 7 is less than negative 13, or negative 4x minus 7 is greater than positive 13. And then we solve both of these. Add 7 to both sides. On the left-hand side, get negative 4x is less than negative 6. Remember, when we divide by a negative, we flip the symbol. I'm dividing by a negative 4. So x is greater than positive 3/2. On the right-hand side, we add 7. Negative 4x is greater than 20. When we divide by negative 4, we have to remember to flip the inequality symbol. So x is less than negative 5. So in set builder notation, the answer is x such that x is greater than 3/2, x is greater than 3/2, or x is less than negative 5. When we graph this, this is going in two different directions. X is less than 5, or x is greater than 3/2. Okay, now we have the absolute value of 5x plus 2 is less than or equal to 17. Because we're going towards the absolute value, we're going to set this equation up as an and statement. So the possible solutions are going to lie between negative 17 and positive 17, just like in class with what we were doing. Because it's the distance from 0. It's going to be between those two things because we're going towards the absolute value. That means we're going towards 0, so it's going this way and this way. It meets in the middle. So we set up an equation where we take this out, and it's going to be equal to negative 17 is less than or equal to 5x plus 2 is less than or equal to positive 17.